So hello again. This is the second part of the class. So far we mainly got the thing from the outside world, let's say the result of your experiment or something like that, or data from COVID or whatever, and we look at the numbers, make some basic summaries. Okay, there's a longer story, but let's talk about later. But we did some basic plots, and I'm going to show you a little more on that. But let's see. Okay, but we're going to do graphical thing. This is a graphical class. Let's see if everything is right. So as we said before, there are several ways to do things in R. And of course, there are other systems, but we already made a decision using R. People use Python, people use other systems. You can, many of the things, not all, but many of these you can do with Excel. So there are decisions that have been made. And one of the decisions is what kind of graphical system we are going to use. We typically use the basic plot, the one that comes already packaged with R. That is what we teach every year. However, this time I want to teach you the modern way, which is, by the way, what you find if you see papers published in the recent years, everybody's using the new system. Remember that at the end, the goal of this course is that they help you to prepare a paper with the graphics and the plot. I kind of imagine like a kind of exam that we can have is like write a paper about COVID or something like that. So, point to keep in mind is this: there are basic plots. We are going to tell the base plot, the one that we are going to use in this class, and we will see more details later with the new system. The new system is called ggplot or ggplot. We're going to see that later. Right now, I'm going to show you the basic plot, and the point is that we're using them only for that exploration. Essentially, the point is that you use a plot for two reasons. One reason is to write the paper, to make a beautiful plot. And you can do many of the things with the classical plot, but this is not what people are doing now, and they're kind of easy things are easy, but hard things are not so easy. It can take some time. And later we will see a system that easy things are not so easy, but hard things are very easy. So why we teach this? Because it's still a good tool to understand data, to do what we call here data exploration. Okay. We will not spend a lot of time making this plot nicer than we did in previous years. So we are just doing nice plots. No, sorry, not nice plot, basic plots that will allow you to understand the data. Okay, so let's see. Again, we are working with the same data. Just remind you here. We go to the basic idea, the idea of one image worth 1,000 words. No? So there are things that you can see visually much better than you can see with the text. Or at least people would like to have an idea what is happening. So working with the student data, I'm working with the weight, for example, here. So what is the format here? We have the vector. This is a vector because it's a column of the data frame. Every column is a vector. And we just say plot of that vector, and you get something like this. So in the horizontal, there is a word saying index, which essentially means position inside the vector. And you have the different values from, this is the first, the second, third, tuck, 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 tuck. And in the vertical, we have the range of values and the name of the variable. In this case, students, dollar, weight, kilos. You get 14, 50, 16. So the first thing that you get is a big vision here is like, what are the minimum values? You can quickly find what is the minimum value, something a little bit over 40. What are the maximum values? Something over 100. And you see that visually, you find that most of the cases are, let's say, between 50 and 90, let's say. Visually, you can see.
Sorry for interrupt, but I didn't understand index mean.
Index is, okay, let me show you the vector. Let's do this thing. Let's do this thing. Do we have the vector here in there? Yeah, we have students here. So let me hide this thing. The vector that we are plotting here is called students weight. Weight kilos, weight, tau, okay. So these are the different values. Some values are missing. Good to remember that some values are missing. The first element is 67. That is the element in index 67. Then the second, third, and for example, this 57 is in the index 19, and the last one is 80 is 117. So the position of every value inside the vector is what I'm calling the index. Okay, so the first, the second, the third.
Thank you.
So don't worry, I appreciate the question. The idea is always, the purpose of the classes here is that you ask questions. You know, in general, we can upload the video to YouTube and you're watching YouTube, and what is the point of having the class if you can watch in YouTube? The point is that you ask questions. So this is the first, this is the second, the third is kind of missing. It's not very easy to see here, but there is a missing case. So you remember it was 57, 55, something like that. But the basic point is that you go from left to right in the same order that you go from left to right here. Okay? So you see the vector from to the side. Then in the graphical version, you also see the vector to the side. Okay? In this case, the order is essentially the order in which people answer the question. It's not, has not a deeper meaning. But it's just to see the things that are in the vector. Okay? It's just to give you an idea what is happening. In some cases, the order is important. Like, for example, in the COVID data, every column is a different day. Okay? Every horizontal position is a different day. Here, it's just the order in the table. Okay? So how we read this thing? Well, essentially the question that you say, the vector index is a number from 1 to the length of the vector. If you have 100 elements, it's 100 to 100. If you have 1,000, it's 1 to 1,000. The vertical axis is the value of the element. And so if a vector in the position number 3 contains the value 170, then you have a point at 3, 170. In this case, for example, we say, let's make an example. We say that, let's say here, let's find something funny. Let's say this is something not too hard. 1, 2, 3, 4, 5. 5 is 68, okay? The value of 68 is in column number 5. So we go to the graphic. 110. So 1, 2, 3, there is 3 is missing for 5, so 68. This one, no? Eventually, you would like to have something like you put the mouse and give you a value. We say 68? 68, yeah. 74, 68. So 75, 55, not available, 74, 68. Oh my gosh. So 75, 55, not available, 78, 68, 55. So, okay. 1 point for every element in the vector. If the number is higher, it will go higher. If the number is lower, it will go lower. Okay. Any question? No? Ask question. Ask question. Another example, very simple. You can do the same with the height. No difference here. No? I mean, the values are different because the height in centimeters is between 150 and 200. And you see quickly what are the biggest, what are the smallest, and what are most of the people. Kind of, you get an idea. So sometimes you will like to plot with lines. So how you plot with lines? You add one option here. You put the vector, comma, and you have an option called type. There are several types, but for us, since we're doing just exploration, there are two options that are useful. One is lines, and the other is O, meaning over, that is lines and dots, dots over line, essentially. No? So you notice here that the line is broken, and the line is broken because you have non-available data. So when the data is not available, you don't draw anything, and the line cannot be drawn there. So you only have lines between elements that are available. And here it is, if in this case, for example, the graphic is kind of narrow, it's hard to follow the values, but if you put the circle, it's kind of easy to see. So when you use line, when you use dots or points, or when you use both at the same time, it depends a little bit on the graphic, but I will say in general terms, I have a general idea that lines, to be honest, are mostly used to tell a story of changing through time. So because here, for example, in the plot that we are showing, this movement, it's not really meaning anything. Because the order of the values in this vector is not meaning anything. What I mean is that you can change the order of the students in the list. If you have the list of students, change the order. The results are the same. The idea is the same. The people are the same. But lines are useful when you are speaking about time. I will show you an example in a minute. Using over is the option O when you have dots and lines at the same time. It's better to see the individual points in the line. And if you don't say anything, the default is type P, meaning points. So essentially, I'm showing you three kinds of plot. There are more, but these are the basics that we work on. If you say type P or nothing, you will have a point like this one. If you say type L, you get lines. If you say type O, you get over lines and points. Okay. So one example when you do want to use lines is something that changes with time. For example, COVID cases. This is probably data from Friday. I didn't update it today, but here the line is telling a story. And maybe I want to make a pause here. The purpose at the end, as we say, is to write a paper. And the paper, when you want to communicate your result, what you are essentially doing is you are telling a story. The plot that you want to write, to draw, the plot that you want to show is the plot that convey the story that you want to say. I mean, or the story that the data say. In the case of COVID, the story, well, one of the stories important is how many cases you have every day and how they change every day. So in this case, the horizontal line is important because it's time. This is essentially beginning of March. And this is the high that we have in April. And this is the status that we had when the exam started. And then during the midterm, this is how the number of cases increased. Daily number of cases, new cases in Turkey, official. So yeah, stay at home. In the case of students, the horizontal line was not meaningful like in this COVID case. There's a couple of options that we sometimes will like to use, just like making a zoom. For example, here you see that the data, there are two strategies. If you are clever, you can kind of do a filter to filter the data that you like. I mean, you remember that this is a data frame and we have the tools like mutate and filter, all the tools that we have for manipulator. That is certainly a strategy, and we're going to use something like that later. But right now I want to show you this idea that you still using type line. We have an option that X limits X for the horizontal line, and you have Y if you want to do for the vertical line. Here in particular, I want to focus in this range between the day 80 and the day 150, which is the first peak. How I do? Well, I essentially say that the limit is a vector with two values. So C is to make a vector, and you have minimum value, maximum value. And that essentially makes that the line starts here and finish here. Still, the vertical is depending of all the data. If I wanted to make the real zoom, I probably have to also specify Y limit. Okay, we have to load this data. Well, maybe we can do it. But let's do it. Let's do it now. Let's do it now. What do you say? How we load this data? Help me with this. I'm going to R. And in R, I have the COVID data here, December. Okay, this is not the most updated, but maybe I can use the other. So COVID is real comma separated value, no? Comma separated value. So I think the updated version I have in my download folder. Downloads, and it's World Health Organization. COVID data, this one. Okay, this is COVID, and then we say Turkey, or I say let's COVID. I learned this trick. If I press Control Shift M, yeah, you press Control Shift M in your computer, and you get this symbol, the pipe. Instead of percentage, is kind of hard to type one by one. You press Control Shift M. Control Shift M, and you get the symbol. So I will filter for country equal to Turkey, equal Turkey.
Sorry, can you send the COVID file from chat, the one you are working with right now? Or is it the same?
It's the one Friday. I mean, you can download the official one, and the one that you got for yeah. I mean, I'm using one that I got on Friday, but it will not be a big difference. The idea will be the same. So essentially, you have two options. You can use the same that we asked for the exam, which is good enough for what we are going to do today. Or if you want to update it, go and get the data from today. It's better, no? In fact, we probably can do that, but okay, let's do it simple. But later we can do it today.
Okay.
Country, Turkey, and when country, and here we are going to store in Turkey, vector called Turkey, no? Why I didn't get this error? Because I forget to say library deployer. Okay. With warning not important for now, and we do it, and now it works. So Turkey. Okay, so on Turkey.new cases is all this vector, which you see in the screen. Yeah, it looks something, but it's hard to get a clear idea what is happening. So let me make it a little lighter. So Control. I'm doing again. These are the real number, but it's hard to get an idea of what is happening. But if we do plot Turkey new cases, you here the plot opens and you got this thing. And here you see, since I didn't say lines, it's going to use points, and the points are nice, but they tend to accumulate so much that it's hard to see what is happening here. And there is this jump here and it's hard to follow. So in this case, it is better to use type equal line. And you get the plot that we were showing in the slide. If you get updated data, better. Then there is an option that I was saying, the horizontal limit, the X limit, is going to be a vector. Sorry, xlim, why I got xlim. Xlim is a vector, and minimum 80, maximum 150. I'm looking more or less this range, no? Then when I do the sum, it works, but still the maximum is the maximum of all data. So I want to also to make a sum between 0 and I don't know, 10,000. So this is the vertical limit. It's going to be a vector between 0 and 10,000, something like that, no? I am counting right? Yes. You can see then that it is more like 6,000. So, okay, this is the first peak, maybe even 5.5. So, as you see, this is a tool for exploring what is happening here. I can quickly make a plot and see quickly what is happening. Okay, you take a vector, any column or vector that you created, and you can quickly take a look at it, make zooms, and see what is happening. That is the purpose of this class, a tool to see what is happening. So if you wanted to, here we have a story, we can come back. If we want to see, for example, this peak, we will say something like 340 and 350, I don't know, 348. So maybe let's see what's happening the other side. If we go to, let's say 330 to 350. Yeah, this is a, let's make it a little before 325. And here you realize that it can, I mean, in my opinion, it can be better seen if we put some points here. So I will use over. You get a little better the story. So if there are a lot of points, then lines are better. But if they move a lot, well, you will see in some cases one are better than others. Okay, it depends a lot of if you are speaking about time or if you are speaking about how much data you have. If you have, I mean, if you have 1 million numbers, making a plot will probably not help you. Okay, this is something that works well with, I don't know, 1,000, 2,000 points. But if you do very much, you will not see anything. So we have, going back to the slides, we can plot points and lines, and we can essentially choose horizontal and vertical limits to kind of make a zoom. Okay, fine. There is another option that you may like to see. It is bar plots. Sometimes they are nicer and kind of the same idea, but in fact, bar plots are useful in this. But okay, I will show you a couple of cases with bar plots are useful. So kind of the same thing if you see, but let's go back. No, here. So so instead of type O, I write nothing. And instead of plot, I use bar plot. The same horizontal limit, the same command. Not very clear. No. No, doesn't work well, no? I press the button. No, not helping. What can we do here? Let's start with plot everything. Let's see what's happening here. Maybe I'm wrong here. Yeah, this is the plot of everything. And then let's see if I can choose the limit in, we say, what was the first that we say? 80 and 150. It's not very clear what is happening here. Yeah, so maybe bar plot is not good when you have so many data. Okay. Why? Because I mean, there is something happening here. Like it is. Yeah, I know what is happening. We are still looking everything. We are still looking all the data, but we are only focusing the screen in the condition and the coordinate that we say. So the bar plot will show all the numbers and focus on part of them, but they are not hiding the ones that are outside. Let's see if I can make a better zoom here. Let's say something like this. Yeah. But if you see the lines comes here and keeps going to the other side. So let's see if I go, for example, from 150 to 250. Yeah, you see. This is 150, this is 250, but the bar plot keeps showing everything. So yeah, in this case, it's not necessarily a good tool. I will use it later for other purpose that is useful, but to explore the data, the normal plot was better. I don't want to confuse you, so ask questions. So you see here, I'm essentially trying to show the same. And the point here with the box plot is that even if I choose the limit, it's still showing things that are outside. Got it? So when the vector is large, it looks like a gray thing. But here you have all the story. Sometimes it's nice. In fact, it's the plot. The reason why I want to do this is because I was thinking the plot in the World Health Organization. Let's see if we can do it. So World Health Organization. These are data that are official, like the Turkish government give this data to World Health Organization. And here, this is the plot that we are trying to do. Okay. Daily and well, weekly. It's a nice question. We can try later to make it weekly. And we have this one like the death, a number of daily death. How we will do this one? Any guess how you make this one? Come on, tell me. You know how to make this plot. Let's make this plot.
Can you say again? Yeah,
I will say again. These are the data that we have in our table. This first plot here is the one that we just made. No, it's like this one. Let me show you. Okay, maybe going a minute back is this plot. Make a zoom. This one. Okay, this is the horizontal is the time, one value every day, and you get something like this. Okay, which is this plot. Okay, that is the number of cases every day. My question is how you make the second plot.
We can use new death part instead of new cases.
Yes.
So how you will write the complete command? Yeah, that is the idea. You are right. But what is the complete command?
I can write on chat.
Yeah, of course. That's what I was asking. Please write in the chat. What is the chat? What is the chat?
That's...
Everybody can give their guess in the chat, and because Because the trick is that you have to try it on your own. No? So, yeah, we can try both. Yeah, but to get exactly the same plot is bar plot. Interesting. Okay, we should try the 3 commands. The one that I think is the correct one is the one that Mirai give, because it's a bar plot with the number of new deaths. Zoom. Let's see the zoom. This one. So start at 0 and then go the peak in springtime. This was summer, and then we come back and here we are now. And that is this plot. By the way, yesterday was a little better. You know, I am missing this 3 last day of the weekend, and the weekend was a little better. Just a little. So yeah, what happens if we do the other one? If we do plot, instead of bar plot, we do plot. We get something that is similar, but it's not exactly the same look. To be honest, for the exploration, plot and bar plot are probably useful. So it's just that this plot doesn't look as clean, but we are just exploring data. We are not worrying very much about the aesthetic part, not yet. Then the next question was cumulative depth. What do we do instead of new depth? We do cumulative depth. You know what is cumulative depth? What is the meaning of cumulative? It's super important for us.
Total, that's.
Yeah, so
from
every day,
beginning.
yeah, from the beginning, total from the beginning, exactly. It's like the number of people that die one day plus all the people that die before. So these are always growing because they are not negative death here. So, and in this case, you get with this click. If you click here in the World Health Organization, you get the cumulative values. That's the cumulative number of cases, that's the cumulative case number of death. And our plot was kind of the same. But maybe instead of plot, we can do bar plot. Yeah, so this is the plot that corresponds to. So, well, the good part, okay, if we can call it good in this context, but the good part is that we can make this plot. If we get the data from World Health Organization, we can make this plot, and therefore you are able to write a short paper saying this is what's happening here. So, okay, this is already useful. It's so useful that the World Health Organization is doing. What we have here then. So that is the story of bar plot. But in fact, bar plots, as you see, they are not very, very useful for this kind of data, but they are useful for when you have a table. For example, you get students' English level. You remember that we have the English level, and you can count how many of them are in every case. So let's do. let's go one by one. We can do also in this. You should be able to see that this command and this command are essentially the same thing, written in a different way. So let's go one by one. Student English level is here. Different number. This is hard to understand because it's kind of every result for everyone. So you want to do something a little nicer, and you do table. You count them, and you get the number. That is what we did before. And then you would like to see that, and that is what I say. You put this in bar plot. So yeah, this is still something like. Not all texts are shown here. So if you want to do it more beautiful, there's some trick that we can do here. But again, we are going to do that later. This is just to get an idea of what is happening. Okay, and here you see that they are not sorted, ordered in the good way. It is better to use the factor. I don't have the factor here, but I have it in the slides. So if you have a factor, and here is the trick, if you have a factor, you can just plot. If you plot a factor, there will be automatically a bar plot. So plot for numbers show lines or circles. Plot for factors is doing bar plot. And the order is the order of the levels. And here I sorted in the order that we like it, from knowing little, knowing more. And this kind of make more sense. No, you see a pattern here that most of the people is understanding movie without subtitles as technical papers. No, that is technical papers, movies without subtitles. And yeah, this is fluent, this is native, and this is Shakespeare. And you kind of see very few people here, and most people in the center. Like you will expect something like this. So to do this, we have to rebuild the factor, but I don't have the factor here. And well, if you are very eager, we can do it. But let's continue, and we have time. We'll try this later, or you do it. I mean, to do this, you need this column that we don't have in this data. I have to make it. And how we make it, that was the previous class. We created with factor, and we have to define the levels, okay? So later we can copy and paste from the old class, but later, okay? If you are not in a hurry. Let's do the class, and then if we have time, we do this question again. Fine? Any question? So in other words, bar plots are nice when you have a few columns, a few bars. You have like 5 or 10, they are fine. If you have many, it's kind of confusing. And they work well with factors. But sometimes you want to do the same with numbers. So how we do with numbers, we essentially have to group numbers. The problem with numbers, a difference of factors, is that number can grow like in very small steps, like 0, 0.1, 0.12, 0.123. So they are not automatically separated. Here, you are you know English or you don't know English. You are either English Bilmiorum or you are I understand movies without subtitles. There is no in between. With numbers, you can always have something in between. So what we do is we have something, we need to do with number, we need essentially to group numbers that are similar together and then count them. And that has a name. The name of that idea is called histogram. Histograms are this kind of plot. Histogram is kind of a bar plot that groups all the data together. So it's grouping and counting in one step. So here we have the data as we show with plot from the beginning to the end. Here, what is happening is that this data is automatically split in groups. There are some rules here that the number of columns is, there is an automatic level here. So you have from 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, 100 to 110. We can change this later. We can change the number of columns. But essentially what we say is that we have 10 people between 40 and 50 in this range. Okay.
Is it like group by function?
It is like group by. Except the point is that group by you have to define one column that is either I mean you have to define the groups first.
Mm-hmm.
It is a group by, but group by allow you to count, but how you define the groups, you have to define this range. This is like 40 to 50, that is one group, 50 to 60. And histogram is making that group by automatically.
Okay.
Here frequency means how many times. Frequency literal means how frequent it is, how many times it happened. So we have like 28 people between 50 and 60 here in this range. And 25, 26 people between 60 and 70. Notice that this is not something that we can do directly with the tools that we have right now. For example, if I say, let me close this one. If I say table of student, what is this weight, no? This is weight, where? Yes, weight. You have, if you do by student weight, you only have the different numbers, like one person with 42.5, 6 person with 47. But we would like to group all this in one set. These are the 10 people between 40 and 50. Then from 50 to 60, this one. Then from 60 to 70, you see? So we need to group them in similar elements before counting. And we can do, there are some tools for that, obviously, but instead of showing you the step by step, I prefer showing you the big picture. The basic idea, and that is, this is something that is more useful than you can see right now, but somehow this is what we really care, you know, because to be honest, in this big picture, we don't care very much who is this person, who is the smallest, not in this case at least, or in which order they come. I mean, since this data has no time involved, time is not important, the order of the values is not important, then we just forget about the order and we care about the big picture here. So here we have the first student and we have the last student. But first or last are meaningless. It's just the order that you answer the question. It is much more interesting seeing how much people are heavy, how much people are light, and how many people are in between. That is telling you a much better story. You quickly see what is happening here. You see that the average should be something between here, for example. And the median is probably here also. And the one quartile should be here. The other second quartile will say the median. The third quartile will be more or less here. There are few people that are very heavy. There are also few people that are light, but there are much more light people than heavy people. You get an idea of the shape of the group. And you immediately see the minimum and maximum. So you get an idea of what is happening very quickly. So in general, when you get a set of data, and sorry, there is a point that you can make this plot with 100 or with 1 million. Now, if you have a lot of data, a histogram will always give you a good idea what is happening. What are the values, what are things that are happening, okay? Now, they only make sense when time is not an issue. So you can essentially separate data and data that where time is important from data that time is not important.
Sequences is the important in plots and histogram, and quantity is important in histogram. Is it true?
I mean, quantity is always important. The point histogram is not looking at the index. And the question, basic question is, is the index important or not? In the case of student weight, the index is not important. It's not connected to the story. In the case of COVID, the index is important because it's the date and it's part of the story. Okay? So when you use histogram, you forget about the index. Is it good or bad? Well, in the case of a student, it's good because index was not meaningful anyway. In the case of COVID, maybe that is not such a good idea. Okay? Yes, no? Better?
Yes, thank you.
Okay. Ask questions, that is the funny part. So, so the idea histogram, you separate numbers, you group numbers in something that is called classes. You put numbers in different classes. And there is a default number, there's automatic, there is a formula, but it's normally good to start with the automatic, and you can change that. And probably we should change that. We'll change the next one. And there is a detail that I'm showing you here. When you do a bar plot, the bars are separated because you have one case and then the other case. Sorry, one case and the other case, and they are different. They are no connection. You either know English or not English. You are male or female. There is no in between. In the other point, the histograms are numbers, and the numbers are not separated. You go for 40 to 49 with you can go step by step. I mean, from 49.9 to 50, you have still infinite numbers in between. So you cannot really separate 40 to 50. So when you do a bar plot, you will see that they are separated. When you do a histogram, you see that they are always connected and they're not spaced between the columns. Now, we can separate the number of classes. We can choose the number of classes with this option in class. In class is the number of classes. So here, by default, they make it like this. We didn't say anything and they split like this. But if I want to have more, you can say here. And here I have 40 to 45, 45 to 50. So now the point is this. The drawing of the histogram will change depending on the number of classes. And some cases will give you more information than others. Some will give you more. And the point is this. If you choose very small number of classes, you will see nothing. And if you choose too many classes, you also see nothing. Let's do this exercise. Let's do this exercise. No, it's a copy. Copy. Okay. So first, I'm going to start with the default. Okay, you see here they are connected. In the bar plot separated, in the histogram they are connected. The values here correspond to the values of the vector. So now I was saying that the other option was to go with 20 classes, and you see a little more detail. If I use, let's say, 200 classes, I will get something that is, I mean, there are so many classes that they are too small. You are not grouping things together, like everybody is different. So it's not showing you the big picture. And if you go to the other limit and you have, let's say, 2 classes, you get nothing. And here you see a little light that will tell you that the number of classes is not exactly what you get, is kind of a suggestion, okay? So I asked for 2 and I got 3, but it's kind of similar.
Can I ask something again?
Yes, of course. The only thing that you cannot ask if you can ask question. You just ask the question.
Okay. Students' weight vector has non-available value. I remember like this.
Ah, good question.
But
very good question.
histograms has not. this value?
Yeah, good question. Good question.
Why?
Well, I don't know exactly, but I guess that the histogram is showing you counting only the values that are available. They're not available, not in the total count. Essentially, because you're essentially, how many times I see this number? If you have a not available, you didn't see it. In the case of plot that we had, when you have not available, they were shown like missing cases. We had a nice thing here. Let me go back. No, that was the morning. Was the plot? Did we do the plot? No, we didn't do the plot here. Anyway, let's make it. So you say plot student weight kilos. I remember now we have some factor here. Number of class, no, plot type. Let's say O. So here the missing data is essentially represented by this broken line. So there is nothing connected here, nothing connected here. The broken line is because there is a missing value. But that happens, as you see, only in the horizontal line. I mean, when you see the horizontal line, when you see all the cases, and some of the data are missing, then you see that the line is broken. Okay? Now the histogram is not taking the horizontal line. It's not taking the position in the vector as part of the data. You don't care about that thing. That is why when you do the histogram, you get only the number of cases that is that you can count. The non-available don't count. That is the bottom line. Non-available data don't count for the histogram. And as you see, if I have 10 or 20 classes, I kind of see a nice picture of what is happening. 20 classes probably for me is better. Like you see that there are very few people here, then it increases, and the big bulk is here, and there are kind of a space here, and some people jumping here that are kind of outside the range. And then with what else we have here? The history. If you have more classes, you kind of don't see the big picture. So too many classes is bad, too few classes is bad. There is kind of a sweet spot of the number of classes that tell you a useful story. So there are some criteria that is implicit in this automatic rule. And the point is, my point is, when you do the histogram, start with the default, and if you don't like, try to use a little more, but not too much. Not too little, not too much. I just remember that in a student, we have some factors, so we can do plot student handedness, and you see that automatically bar plot. So if we do plot of a factor, you get a bar plot. If I use the text version, I get an error. You remember that in student, I choose the column handedness to be a factor. In student 2, I didn't choose. It's text. So summary student handedness is a factor. The summary works like this. And if you take the other table that was text, it will say just that is text. So when in the case that the column can be a factor, there is an advantage of using it as a factor. Summary works better, plot works better. I mean, you can always convert it automatically to a factor. For example, if I want to print this one, I can always wrap this. I can probably do something like this. I put the parentheses and I go here and I say factor. Like in one step, I convert it to a factor and I plot it. But if you are doing that, you better use the column as a factor. Fine. Okay, the last kind of plot that we have here is this one. Another way. This is called, have you seen something like this? No, sometimes you see in papers. This is the advanced one. This is called Boxplot. Boxplot is a graphical version of summary, essentially. So let's make it the thing here. We are plotting weight, no? So let's take a look at the summary of weight. And box plot of this. Okay. So what I'm saying here is this: in a box plot, we have some mark here. The center line, this dark line here, is the median. Okay, not the average, not the mean, the median. The value that 50% is below the 50%. The lower box is the first quartile. The upper box is the third quartile. In other words, you have this is the 25% and this is the 75%. Therefore, you have 50% of cases in between here. Okay, then there is another range calculated with a different formula that will give you 95% of cases, at least 95% of cases. Okay. If everything is normal, literally, you should get everybody or most of the cases between here and here. And the point that you see outside are outliers. These lines here are called whiskers. You know what is whisker?
Is it like cat whiskers?
Exactly. Exactly. They are the mustache of the cat. And the idea that, you know, that they use it to sense what is outside is kind of extended to the side of it. So yeah, so these are the whiskers of the thing. So let's see in the R. So what I'm saying that the median is 65. You see here. The first quartile is 56 here. The third quartile is 75 here. These two are not directly here, but you see that there are two cases that kind of out of range, outliers. They are kind of, they are different from the rest of the group. And you can also see it here in this plot that we have here, maybe here. Here is more clear that the big group is this one, and it goes up, goes down. And essentially, if everything go with this shape, essentially you have 0 here. And you have 2 persons, I will guess 2 boys, that are here, that are too much higher for what we expect to be. Okay? So, so the box plot, no, again, the whisker, it is essentially one column in one time. Sorry, not the whisker, the box plot. It's essentially in one column a histogram. And why we want to do this? Because essentially we want to see how this histogram change with time, for example. How this distribution change or something. Or for example, we would like to make this separated for boys and girls to see if they look different. Going back to the slides, whisker give you 95% of the cases, point are outliers. So you see that there are 2 outliers, and whisker are effectively cut. So in summary, plot is uses to show a vector. We use lines only for time-dependent data. I kind of I didn't realize before. This is something I realized preparing this class, but using lines when your data is not time-dependent is kind of confusing. It's kind of giving you a bad message. So for COVID, it makes sense to use lines. For weight, it doesn't make sense. Unless you are saying, for example, if you are controlling, let's say, you're in a diet and you want to see if your weight is going up or going down, then you will use a line. But if you have different people that have different weight in a given date, then the time is not a variable there. Bar plots work well for small vector, and you can use bar plot flavor for counting things, or if you have a factor, use plot them. So plot work with factors and with numbers, not with text. Histogram is a big summary of a set of numeric data. Histogram is kind of box plot for numbers, okay? Bar plot, and here you see, I make this confusion, so please don't. Bar plots and box plots are different. I tend to confuse them, and sometimes I say it wrong. So just be careful. This is a box plot. They are drawing a box, and this is a bar plot. Okay, bars are vertical bars, and boxes are boxes. Okay, bars start in 0. Boxes have minimum and maximum. Okay, any question? You are either understanding very good or very bad. You are not asking questions. I think that you are understanding. You look like understanding, and that is kind of unexpected thing for me, because I expected that we would take longer for this class. So since we are going fast and you have we have some time, I have the next class. So maybe it's a good time, unless you have a question, I want to show you the next class. It is still draft, so you will allow me to skip some slides, okay? But let's see what happens. So file, class 22. But it will go well now. So any question before I start with this one? Plotting with 2 vectors. As you see, this was planned for next week, but we have time to do it now, and it will be better. So we talk something else next week. We have many nice things to talk next week. What do you say? Any question? No? Shall we go?
Yeah.
Ah, good. Someone say something, because they are all panicking. Like, if I say something, they will hate me. Yeah. Plot with 2 vectors. So again, the same data, and this is called scatter plot. Okay, this is the thing that I don't know why it's not happening. So let's do this in the computer and see what's happening. Okay. As you see, these are the drafts. So what I'm going to do later, I'm going to finish this and upload the video, but you will have already seen it. Let's do to R. So box plot X and Y. Can we do like this? Yes, it worked perfectly. So if I put 2 vectors, I mean, I don't need to write X and Y, you know, these are optional. The first is going to be X, the second is going to be Y. Sometimes I want to just make it explicit, X horizontal, Y vertical. It's the same. The names are optional here. So when I plot 2 vectors, again, we don't see the index. So here, the X is in the horizontal, the Y in the vertical, and you have the points spread here. And you see something that was not obvious before. You see that people that are short are also light. Small people don't have many kilos. And people who are tall are heavy. Okay, there is this tendency line like going in this direction, no? Agree?
Yes.
So that is something that was not obvious from before. If we do two plots together, maybe you will see something, but it's not easy to see just looking at the both plots. So this is something that is useful to plot one vector and the other together. Give me 1 second. I need to make a little adjustment here. Escape. I'm going to open my professor notes and okay, so in other words, the point is that some people will assume that if I plot two vectors, they will go together. But that is not, and it's kind of complicated here. It's one of the things that I don't want to do here, like plotting a height first, and then plotting weight in the same plot. You can do that, but it's not very clear because what are the units here? You have centimeters, and if you plot weight, you have kilos. So what are the units? Centimeters or kilos? And it's hard to compare things that are measured in different units. But in this scattered plot, things make more sense. This horizontal is centimeters, the vertical is kilos, and there's no problem there. Now, skipping the slide that don't work. Okay, let me go here. We'll say Boxplot. Yeah, so this will happen. Let me go to the slide. Sooner or later, you are going to make, because I learned this the wrong way. Sooner or later, you are going to make this problem. You are going to plot not a vector, but all the data frame. You will forget to write $, and instead of student weight or student height, you will write just student. We can do it if you like, but you will get this thing. So this is a funny thing, but it can be useful. How we read this thing? Essentially, if you for any reason you apply plot not to a vector but to the complete data frame, what plot will do is to compare everything with everything. Okay, so some comparisons don't make sense. For example, answer date versus ID doesn't make any sense. But the interesting are these. For example, this line, this row is answer date. Okay, this column is also answer date. So in the diagonal, you see the names of the variables. Okay. So when they cross, they are interesting. For example, what we're seeing, height and weight. Here you have height in the vertical and weight in the horizontal. Here you have height in the horizontal and weight in the vertical. So this is maybe we can do some zoom here if you like. No, it doesn't work, the zoom. I don't know. So we can have a quick look of which variables can go together. For example, here you find that the weight and hand span, the size of your hand and your weight, they have some relationship that is interesting. Then you see other things that are kind of nonsense, like birth date with birthplace. There are no relationship between birth date and birthplace. So essentially, if you see lines that tend to be diagonal, that is interesting. That means that one variable is connected to the other. More weight, more height. Bigger hand span, bigger height, bigger weight. If you have a horizontal line, it means that your ID number, for example, and your birth date are not connected. Your birth date and your ID number, they are not connected. Same vertical line, they are probably meaning nothing. Here is something that is not very easy to see, but we are going to see. This in fact is interesting. Sex in the horizontal and weight in the vertical, and you see that one is lower and the other is higher. Can you guess why? Well, let's go and explore this case. For doing this exploration, I want to propose you something. So the easy way, I mean, not the easy way, the way that you can quickly imagine to write something is to plot two values is just to plot them together. Let's see if we can plot them together. Let's see if we can plot like height and weight, or let's see if I can plot sex. Aha. What happened here? Can you tell me what happened here? Sex is a factor, okay? And I choose sex as the horizontal variable, and weight is the vertical. And we got this box plot. Okay? And you see, if you know that you know what is the box plot, you see what is happening here. You can tell the story. You can see that most of the men are heavier than most of the women. Most of the boys are heavier than most of the girls. Should not be a surprise. Nevertheless, there are some girls that are heavier like most of the men, and some men are lighter as most of the girls. The outliers are men. Okay, the lighter people are girls. Okay, so this is very much like the box plot that we did before, but before I was doing the box plot for everybody. This time, since we got a second vector, I can separate male from female. Essentially, it's like like Buse says, it's a group by. We say we have one factor that say this is male, this is female, and then we see the response. So if I have to guess what is your weight, I will first see if you are boy or girl, if I had to guess. If you are a boy, I will guess that you are in the range between, let's say, 70 and 90, or more exactly 73 to 85. Most probably 78. If you are a girl, I will say that your weight is, let's say, between 55 and 65, most probably 59. What do you say? I am right or not? In your case, I mean.
Yes, you are right.
Did I guess you correctly?
Yes.
There are outliers, of course, that I can be wrong, but in 50% of the cases, I am going to be right. And if you want to be more sure, 95% of cases will be here to here. No? So you see, this plot is already telling you a story that is useful. Okay?
Okay.
Can I ask something?
Yes.
Are these plots chosen by computer automatically, or we just write plot and it shows us box plot?
Yeah, okay. The answer is yes and no, in the sense that when you plot numbers to numbers, you will get one kind of plot. And when you go to plot number to factor, you will get another kind of plot. So it's automatic by the computer, but you choose to plot them. You have some control. Now, to be honest, you can change them. You can say, okay, plot this way, and sometimes it works, sometimes it doesn't work. But the point is that since factors are separated, Yeah, you can make other plot. You can make other plot. This is kind of the automatic, given that you choose factor or numeric. Now, in general, since we're exploring data, in general, these computer decisions are good. 90% of the time, they show you what you want to see. You give you an idea. I agree that you may want to see something else, and please wait me because we are going to see the good way to do that, but kind of in a couple of classes, okay, next year. But this now is just an idea that how can you quickly see what is happening, and let me show you what we are saying essentially. Let me close this one because kind of distract, but just to give you an idea, you say. Let's start with something like weight, no? So say students weight, okay? And you have numbers like this that if you look at them, they are not telling you a very clear story. So you say, the first thing that you can do quickly is to say plot. The first thing should be, let's make plot, what happened here? Aha. I see, I have an idea what is happening here. There's some guy that look outlier and something like this. Okay, if it's not helping very much, if you don't see a tendency, there's no time, then the next is histogram. Aha, better picture of what's happening, you will quickly get. And then you say bar plot, no, box plot. Box plot of student weight. You get an idea what is the minimum, maximum, average, okay, median, outliers. Probably then it's simple. But then you say, okay, I can, and it doesn't work with box plot, but work with plot. I can also plot weight in the vertical, and in the horizontal I will put something else. I will put in the horizontal, I will put student, what is the name? Student height, for example. So two vectors, horizontal and vertical. And yeah, you say, there is interesting, there is a relation, there is some kind of relationship. Now, if the horizontal, instead of being numeric, is a factor like sex, you will see another story. Okay, so each plot is telling you a different story. Here you are saying the difference of weight between male and female. And you can imagine all the story that you say, that men are more heavy than women in general. There are some cases in particular, but in general, blah, blah, blah. Here you say that if you grow in size, you will grow in weight. Okay? You can, well, you can do more things. You can imagine, I can imagine other questions. Here is the big picture. Here we're not separating male and female. Here you see also the, but eventually you will like to have a histogram separated boys and girls. So every one of these plots is telling you different part of the story. Okay, not different story, but different part of the same story, the story of you. Yeah, automatic, but you control the automatic. Now, there is one more idea here. That is essentially the thing that I want to show you, that you have horizontal and vertical. There is one more idea that it will be more practical than you see, formulas. There is something else that we have not seen before. This is a new concept, and we are going to use it mostly next class. Formulas, a priori, is a way to save some writing. Let me show you. So when we are plotting two variables like height in the horizontal and weight in the vertical, we can put horizontal and vertical. There is another way to write that I'm showing you here, and use this symbol. This symbol that you may remember is called tilde, that you have to find in your keyboard. In my keyboard is here, but I don't know in your keyboard. I show you in the first class, one of the first class, I show you the keyboard and I say tilde is going to be important for us. And the logic is this. you want to say that you have one variable, in this case, the weight, and show how it depends. This tilde is meaning depending on. You want to show how the weight change depending on the height of the person. And in practice, this means that instead of writing X and Y, we're writing Y tilde X. I have a summary later, but in the first case, you have horizontal, comma, vertical. In the second, you have vertical tilde horizontal. Why you win? So far, nothing. But the big win is here. When you have the formula, you can forget about putting the data frame and you give it in one part. You say, okay, this is the data frame, and all the things that we put in the formula depend on this data frame. And this is what we are really going to do. This is the way that instead of choosing student dollar, student dollar, student dollar, you say student only one time, and then you do all the plot that you want. So this is going to be much more efficient. So let's see. Let's copy this one. So yeah, this is the same plot that we had before, height horizontal, weight vertical. There is something that we want. If you see, there is it's a small detail, but in some cases it's useful. First, it's easier to write eventually. Come on, where are you? I don't know why it's not working. Open Zoom again. It's not working. Okay, let's forget about it then. But let's make it bigger. So when you use the old format, the one without the tilde, you have students dollar and student dollar, and that looks ugly. But when we do the new one, what we got here? Only the height and weight is kind of cleaner. No dollar sign, nothing confusing here. Height and weight. Okay. So instead of writing dollar, many times we write tilde one time. So if everything goes right, we should be able to make the same plot that we did before. What is happening here? With seeing how this thing changed with weight, with sex. Now the names of the axes are right. Or you can see with the other, you remember handness. Handness. And you see here, for example, that left-handed people are not more heavy or not more, they move in the same range. So sex is a factor that affects the weight. Handedness is not affecting the weight. You see here that there is no, one is containing the other. So it's not a big thing. You can also compare weight with hand span. Handspan. Yeah. So there is some tendency, but it's not very clear because you have some extreme here. To be honest, I think that these people are not very honest. I don't think that anybody got 5 centimeters of handspan. I guess it's more connected to height. Height. How you write this? E.
You should say centimeter.
Ah, good. Height is, yeah, height is not in kilos. Good. And this is essentially what I expect. I expect that if you are bigger, I expect that your hands are bigger. That is the experiment here. The hypothesis I want to test is that people who are bigger have bigger hands, people who are smaller have smaller hands. And we would like to see what is the relationship. We would like to see that. So what I'm showing you now in the second part is that you can plot two vectors at the same time, and you have two ways of doing this. One is horizontal comma vertical, and the second is with a formula. And the formula use this special symbol tilde. And you need to add what is the data frame where you are taking everything. So this is a little more confusing at the beginning, but believe me, we are going to use it. So, well, this is the plot that we saw already. And do I have, well, yeah, look, I finished the next class. So in summary, plot, you can plot one vector, two vector, or a formula. Plot vertical tilde horizontal, it looks very much like plot horizontal comma vertical, and formulas are nicer because you can put the data frame is better than, so this format is nicer than the second format. This is the ugly one, this is the beautiful one. In general, the defaults are good. In other words, especially if you use the formula, the axis names are good and the ranges are good. And you can, let's play with the horizontal and vertical range. So for example, here you will like to see, let's say that we believe that the x limit, I have a trick to show, x limit, it's 10 to, I believe that is over 10. I don't believe that people have this less than 10 centimeters. And I also don't believe the 30. So I will say it's something between 11 and 29, let's say. So I drop the one that are outside. Even this is kind of funny, but at least you see something that seems more meaningful, that small hands, a short height, and then you have some variability. Now you would like to see, maybe this is also depending, because we didn't see, did we see height depending on sex? In other words, are men taller than women? Yeah. In general, men in our class are taller than women. There are some outliers. There are some women that are as high as the average of men, but well, that is what data says. So going back to this previous plot, I would like to see this, but not for everybody, only for men or only for women. You get me? So we can do that. We can do that adding an option called subset. There are more than one way, okay? Maybe next time we will do it with the tidyverse, like a filter or something like that. But this is an easy way to do it in the plot. We will say plot and the subset will be sex equal male, for example, male. And this is the same plot, but only for male. The tendency is kind of more clear because male are taller. So maybe the hand span depends on the, okay, the hand span depends on the height, but it's different from men. From the logic is different. Since men tend to be taller, maybe the relationship is different. That's all. Okay, this is going to be very interesting. I'm trying to understand what's the relationship between your size of your hand, your height, and if sex. I mean, it's kind of a simple question. I not expect to get the Nobel Prize for this, but it's an exercise that is easy to do. And for female, interesting. Look, for female is not so clear. If you see here, we have a very wide range. The line here is not so clear. For men, this horizontal tendency, maybe we have this drawing tool. Do we have drawing tool? Annotate, yeah. I'm saying that there is this tendency in the case of men. But in the case of, can I move? But in the case of women, that tendency is not very clear. I should clean this. This tendency is not so clear. I don't see a very clear line here. So what we want to do, and that will be next class, we want to find what is that line and how much we trust that line. Okay? That is what we are going to do next class. We are trying to find the line. And for that, we need the formula because the lines depend on the formula. Okay? You have cases, and these lines are very easy to follow. I mean, for example, just to go back again, let's make the same exercise, but instead of handspan, let's see weight. No, the original question. What was the original question? Weight versus height. This one. Here the lines. Oh my gosh. Here the lines look much more clear. No. Do you see the tendency here, the tendency line?
Yes.
Good, good, good. Oh my gosh, I am clumsy with the mouse today. This line. Something, well, I'm trying to make a straight line. I'm not making it very well. Here I have a straight line. Something like this, no? We would like to know what is the line, essentially how much kilos you put for every centimeter. If you are 10 centimeters higher, how much kilos you will have, and how good is the line, because there is an error. Of course, these people are too heavy for the size, but that is the body mass index or something like that. No? Then we would like to connect this with here I have to use mouse. We would like to do that separated by sex. So we can ask for the subset where the sex is male. So the line for men and the line for women may be different. No, that happened when I write it wrong, female. That is, if you get this error, essentially mean that you choose the wrong data, no? You see, I didn't write female. Here again, the line is not so clear. There's one small here, but there's not very clear in the high part. And there are some people with the same weight and different size and the same, assuming that people don't lie in the experiment. No? Okay, that will be next class. Do we have something else? No, that is what I have the class here. And I have to, well, I have an idea now to how I will clean this data. And that is the plot that we're going to use right now. Okay, it's not making the best drawing, but it's fast and easy to use. And I can easily give you a homework, like I would draw some plot and I ask you to draw the same plot. Yeah, that is the typical exercise. I will make an exercise. Since all of you already delivered the exam, no? Are you still doing the exam? Yeah.
I sent it. I did
Yeah.
it.
Yeah, I know.
I sent.
Yeah. Yeah, well. Well, anyway, I will do the homework like an exercise. I may give extra time. I mean, not for the next week, but 2 weeks. Just because some people are still doing the exam and I don't want to force them. So, but it's good to do the exercise because it's practice. So today, essentially, you have two summaries, factor and plot. And you see why factors are useful, because factors are useful for plots. And in plot, we got the hardest idea in plot is the box plot, that you have these whiskers and things. So that's it. That is what I had to tell you today. You are a very good student and you went faster than I expected. That is good, by the way, because every year I teach less that I want to teach, less that I think that is good for you to know. So we had the chance to do better this time.